Thank you for introduction. So I'll be talking about today's session. I'll talk about the healthcare applications. So drug discovery is one of the applications in that. So I'll also cover about AI and ML applications in healthcare and as well as drug discovery applications, and also how quantum computing can be applications can be used here in healthcare and uh, for drug discovery also. So I'm about to reach the hotel. Just be in line for 5 minutes, 2 minutes. It's almost I reach the hotel, and I will connect my presentation from my laptop. So before that, like to have some discussion. So we crossed the COVID pandemic situation. So in this case, the traditional drug discovery process, if you take, it would have taken several years to come up with a single drug for any new disease. So traditional way takes around 8 to 10 years to come up for a new drug. That is a old traditional method. Now, due to the increase in supercomputing and other facilities and simulation and environment, so we are able to analyze more number of compounds and we get a better drug in a short period of time. That's why in the COVID time we got the drug we got Covaxin and what is another one? Another uh, vaccine we have used in India, Covaxin and anybody?
Covishield, sir. Covishield.
Yeah, Covishield. Yeah. So we got both of them within a year of time. So that is because of this. Uh, I mean, deep learning methods and simulation environment. They analyzed all the compounds and they came up with a new drug. So that's why that's how the computations. I mean, uh, are currently used for drug discovery process. And another thing is we have several variations of COVID virus. Not only the initial variant, there are different variants also we have faced. So what they do in the drug discovery process is they analyze the whether the current the vaccine, Covishield or Covaxin, will it effective for the variations of the virus. So that is the drug discovery process they analyze. So that is also another genomic analysis they do, whether what you can say the vaccine or medicines we are currently using will be effective on the new variants. That is also another analysis they will do. Okay, this is the basis of drug discovery process and how it is evolved. So works can be done on drug discovery process. So there are some data sets are available even for normal diseases like malaria and other virus diseases. So what they do is they have existing data set for some particular disease. These are the medicines or these are the criteria like that. We have a drug discovery data sets will be available. So what they do analysis is how effective the drugs can be
Login. There's a
recommended. That
login
is also
page.
can be
After
done on the
entering
drug
your
discovery data
email and
sets. So that
password,
is
you
another
can
research area
enter
we
this
can
captcha.
focus on. And also for variation in the identifying the different
Here,
variants.
so many things are there in the
So
left
for
side
one
menu.
bacteria
Assessment
or
is
one
one of the
virus,
thing.
they have a
You
vaccine.
just watch it.
They
I'm
try
clicking the
to
assessment link.
recommend it. I mean, they analyze
Then
it for
immediately
the
our
another
application
variant or
number,
another
date from, and to
virus
date is
also.
there. There is a link.
So there is also some
Blue
data
color
sets are
link is
available.
available. Click
So what
on
we have
that.
to do is we have to analyze
If
the
you are
features
clicking on
and we have
that,
to
it will
classify them and
redirect it
we
to the
have to
assessment
say that
guidelines
whether it is
page. You
how
can
much
read the
accurately it is
guidelines.
able to
Click the checkbox.
classify
This
or predict it
checkbox, you
for
need
the
to
new
click on
virus
it.
or
Then you start the
the new drug. Okay,
assessment.
for the different virus. So some data sets are
Let's
there.
start with the
You can
applications
explore that.
of, is my screen visible, madam?
Yes, sir. Yes, visible.
Okay. So I'll start with application of A&ML in healthcare. Along with that, I'll cover the drug discovery. So this is Surendiran from NIT Puducherry. So I was in a Viva Voice in Kerala. So I was returning back. So that's why it got late. Uh, So we have several applications. Let me skip this one. So in today's applications for healthcare, we'll be discussing about drug discovery, smartwatches, the DICOM standard, and there are mobile apps and games are there. So which can be currently a lot of applications are there for mental health and other things, which is used in research. And so what is AI is making the machines to think as the AI. And what is machine learning is we give the data and it is able to analyze the data and predict the output. That is machine learning. So process the data and gets an output. That is machine learning. Making a machine to think is called as an AI. So in the healthcare, it has started with like decision support system. Like it will give if you give any uh, data like these are the diseases and I have these are the symptoms I have. It will give the recommendation of medicines and all those things. Like decision support system, it was initially it was shorter and yeah. So later it was evolved to you can see about genomic and natural language processing and robotic surgery. Then currently people are working with the drug discovery and personalized medicine and personalized healthcare and also telemedicine and other things. So the and clinical research, these are the things which are currently evolving, currently working on. They are working on. And why we need to have A and ML for healthcare applications is we don't have experienced physicians or doctors. So these A and ML applications for predicting the cancer and all those things, it will be act as a second opinion. So it cannot replace the doctors, but it acts as another opinion for the doctors to provide the suggestions. And we don't have experienced clinicians and availability of expert for 24 by 7 also it's not available. And for any diseases we need to have early detection of diseases and we have to predict the disease as early as possible. And with the initial screening, like let us say we have mammograms or the x-rays images. So once you take any images, so we need not to ask the patient to come frequently uh, to the scan center or anything every month or one thing or every 6 months once to take another scans and all those things. So instead of that, with the single one-time scan data, we should be able to analyze for detection of any early stage of the cancer and all those things. That's why AI and ML or applications are used to avoid frequent patient safety to and to reduce the patient to visit the hospital frequently. So they once they get the data, they analyze and they predict the disease in the early stage. That is the main goal of these applications. And we have different in the physical branch. We have different applications. And if you talk about, we are having smartwatches and other medical devices, other robotic surgery and all those things. The physical branch of the applications. And there is some care bots are there. So these are all available in Japan and China and some places. These robots will act as a like for elderly people. So it gives them reminders for taking medicines and it will guide them to bathrooms and all those things. And if the patient or the person doesn't respond, then it will give a emergency contact call to the emergency numbers. And it also gives the reminders. Let us say the person is having some regular meeting has to be done. Say after 1 month they have to visit the doctor. It will give the reminder and it may even a book with the hospital to. I mean, the next appointment can be booked. So all those will be taken care by CATBots. And this is a her movie, so which is based on AI about the AI. Have anybody have seen this movie? What the movie it is about? The how AI is impacting on our life. Anybody know about this movie? Okay, so here I have Samantha photo. So Samantha is not the actress here, but there is a name. Samantha name is involved here. So what is this movie talks about us? He's a hero who has a problem with his wife and he has got divorced or something like that. And he buys a digital assistant, like a mobile or some digital assistant. It has a new OS called as Samantha. The OS name is Samantha, and it learns. It is a AI OS. So it learns based on the interaction. It tries to learn and it will interact with you like chatbot. And what happens is he falls in love with that chatbot or that OS. So that is a movie about this movie. Her movie name is Her, and it does talks about the impact of AI in our or digital assistants in our life. Okay. So there are some tech companies which are working with the medical field. If we talk about Microsoft, they uh, they provide a lot of support for vision care. So they provide supercomputing facilities and they work with a lot of hospitals to predict yearly diseases or for related to vision care and all those things. So Google is providing support for breast cancer analysis. So they try to analyze any new if you they got trained with a lot of the data, and if you give them some new scan report, it will try to predict whether there is a cancer is there or in the early stage they won't be able to detect the cancer. And precision medicine. So if we talk about Watson, so they works on precision medicine and the drug discovery process. So IBM have supercomputing facility, so that is used for drug discovery process. So in artificial intelligence and healthcare applications, in every area it is used in hospitals. So from keeping well to early detection to diagnosis, decision making, treatment, life care, and research and training. So research, we talk about the genomic sequence, drug discovery, and all those things. That is about the research part. And we talk about the training. So nowadays, the hospitals, the students, medical students are getting trained using virtual reality. So they have a virtual a heart or any human organ. It will be coming virtually in their using AR and VR. So they can able to visualize the organs and the different tissues, blood vessels, and everything. They can able to visualize everything in a visual way. So that is how the A&ML or AR VR is used in medical training also. So these are some applications of A&ML in healthcare. So we have a lot of diseases, diagnosis, and prediction. And main thing is a drug discovery. And also we have personalized medicine. Now they're focusing on personalized medicine and telemedicine. So personalized medicine is they have mobile apps. Nowadays, hospitals are having a mobile apps, and it will they will ask the patient to install that one. So the app gives a reminder. The hospital apps after the patient goes for the treatment. So it gives them the reminders and all those things and books an extra appointment and all those things. A mobile app, it will be tracking the patient behavior and all those things, and it also give a personalized recommendations of medicines and is a decision support system also. And genome analysis and micron analysis are related to similar to drug discovery process. And another one is logistics. So a lot of fake drugs are getting delivered or manufactured. So to avoid that and all those things, they nowadays they use blockchain technology and other machine learning techniques and used in logistics management. And these are other application areas related to healthcare. Use a pointer here. So smartwatches, if we take about smartwatches, so it has able to save a lot of people lives. Even a few months, several months back, in I think in North India, one lady was getting I mean she's using smartwatch. It has given a there is a variation in your the signals it has detected. So it asked it given a warning. So she went and checked, and it was found that there is a blockage in the heart. So that is how smartwatches are helping us. And the future will be like a lot of companies are working with smartwatches to include more and more sensors. So because it will not replace the hospitals, but most of the facilities is comes into the smartwatches. Even a Samsung, and my friend is there in the Samsung, so she used to tell that they are working with a lot of sensors into the mobile, I mean smartwatches, so that they can able to predict uh, most of the based on the signals and everything, they'll predict most of the diseases or anything. So so that is what they are working on. And here, how A and ML and all those things will comes here is, so we have the IoT data. That IoT data is that like we have the several monitoring, like your fitness and your walking patterns, sleep patterns. In case of health monitoring, we have BP, heart rate, nervous, and all those readings. It will store the user's data. So not only the daily data, it will store for monthly or yearly data, and it uses the past data, the all those data, what it is received, it will be analyzed. And so there the IoT based us the signals, the all these data, will be used the from the several sensors, and the past history of data will be using it to apply for machine learning algorithms, and where they will try to analyze some patterns from the users, and way for which a lot of companies are working on. So they're trying to incorporate more and more sensors into that. So early detection of any cancers and all those things. I think people have now, we have a lot of works are going on. Early stage of detection of any cancer or any diseases. And decision support systems, timely decision or clinical decision support systems. So here, what they do is based on the past medical history and all those things, they try to uh, I mean, based on the past history, they may possibility of some illness or anything can be there. So they may use the past data and they will try to predict uh, some diseases or possibility of spreading of disease. And also, not only in the patient wise. So if you take about the health centers, see we have several health centers in each in your locality and all those things. So if you talk about in summer, we have some matrasai and other diseases will come. In case of winter season and rainy season, we'll get some flu virus. So sometimes we will get a malaria and a dengue fever. So these data, they how many people have treated in particular region and all those things, they have the past data, and still they are using it to predict what is the possibility of next outbreak in particular regions. So based on that analysis, they take precaution measures. The government is taking precaution measure. So for that, they use a decision making here. Still, the governments are using with private party in the just a minute. Hello. After 8. Okay. And for treatment, so here we have the drug discovery process, and in this one we analyze the genomic analysis. So the variation of the DNA structure. So that is a new variant and all those things. Whether the same medicines can be applicable for variations, different diseases and all those things. The existing vaccine can be used for the variant and all those things. They do analysis with the genomic analysis or DNA analysis. Uh, and I already I said about the training. So AR and VR is used for training purpose and medical training. So this is how they use a virtual reality. So they will be able to see the different organs and all those things, and they can able to visually learn the medical the medical field. So this is the different types of AI/ML applications in healthcare. Different companies are working on that. So not only in AI chatbots, we have telemedicine, lifestyle management to disease management to medical records. Even for medical records, it has to be with integrated with NLP and transcription processing and all those things. And a lot of companies are working with data analytics and for medical imaging to hospital management system. And we have the genetic research and drug discovery. There are several companies which works on that particular area. Okay. And also there are several companies which focus on mental health and women's health also. And currently, a lot of works are focusing on the skin diseases. If you talk about the seashore regions and all those things, in even in Karaikal, I'm in from Karaikal. So I talked with some when I mission doctor. He said that the because it's humidity is high and the people in those seashore area they may have some skin cancer. So different variations can be possible. So that also they are analyzing and they are focusing now. So you can use MATLAB or OpenCV or Python programming for most of your uh, medical related works. And the DICOM standard, this is a standard that is available for all the most of the medical data sets and all those things. So I'll come to that. Are the other standards are there? I'll come to that. So now I come to the drug discovery process. So here in the drug discovery process, what they do is they analyze 15,000 compounds, and it is a general, it is a traditional method. It takes around, I think it is around 14 to 15 years. There's a time duration is mentioned here. So what they do is they manually in the lab they analyze 15,000 compounds, and from that they'll choose the 500 compounds. That is a variation, different combinations, and they do a preclinical trial. Then they do the clinical trial, and maybe with different patients or with or some maybe with some animals and all those things. And the from the 10 compounds they'll come up with a one drug. One out of the 10, one will be approved. That will be called as a drug. So this is a traditional way of any new drug for any, I mean, new the drug for any new disease. So the traditional method takes analyzing all these things in the lab and all those things. It will take several years of time. So how this is reduced to current supercomputing facilities and all those things, how it has evolved us. This is the one comparison. So here we have standard discovery in the left side, and we have the MyCar is one of the supercomputing facilities available for drug discovery process. So MyCar. So here we have on the left side we have the standard the lab-based drug discovery process. So here they use the lab-based. So here it will take 20,000 compounds they are analyzing, but here you can take the simulation. It is a simulation-based. So MyCar is simulation-based supercomputing facility. So here they analyze with 30 lakh compounds. So here they analyze only 20,000 compounds or the variations of the medicines and all those things. So here we are able to analyze with 30 lakh. So the combinations we able to analyze is very high. So we'll get a better drug. And this takes several years or months and time. And since it is a simulation environment, it will take only several days or weeks. And finally, we are able to get the drug. So here, if you take this is standard drug discovery process. It's a deep learning based or simulation based. So that's why we got in the COVID time, we got lesser time to get the medicine. I mean, within a period of 1 year, we were able to get a Covaxin and Covishield. And actually, what is this Covishield and Covaxin vaccines? How it works? Anybody knows? Anybody know about how the vaccine works? What will be in the Covaxin and Covishield vaccine? What it contains? Any idea? Anyone?
The dead cells of viruses, sir.
Yeah, madam, you are correct. So it contains the dead cells or the virus without any power. It's a dummy virus. We call it as a dummy virus. So what it happens is they remove the virus power and everything. They make it as a dummy virus. So they will inject that virus into dummy virus into our body. That is a vaccine. So the our body tries to learn to attack that new virus. That is a vaccine is the dummy virus. So what our body will try to learn us. That's why we get a fever when we take a vaccine. So what will happen is we'll get a fever. So because our body tries to attack that dummy virus. So why the vaccine is used here is it makes our body to train how to handle the new virus. So that's what they do with the vaccine. So they make our body to train with this virus, how to attack the virus. So if a real virus comes, so already it is trained and so it tries to attack in an effective way. That's why vaccines. This is how the vaccines work. And if you talk about the standards in medical imaging, so this is also a lot of research scopes are there. Any data, any medical data, even whether that is a drug discovery or medical scan images or anything. So they store in case of drug discovery process, we have FATCHA, FATCHA, and so many other formats are there for drug discovery because we store them into genomic formats, ATCG. So DNA structure. So that we have different formats are there. And here in case of medical data, the medical data, so we have several formats are there like DICOM, NIFT, NRD, Analyze. And Philips also they have their own format and all those things. So if you go to hospital for any disease, okay, nowadays they're not giving any hard copy of the scan report. They are giving only the CD or a digital email copy to the doctor. So what they do is they send the data in this format, so they'll be able to view it in their system. So mostly they go with DICOM standard. That is, we have DICOM views are there. So in these medical formats, a lot of research work can be done. Even the PhD work can be done. I have seen on PhD work they worked on DICOM standard. So there you can use encryption, how to store the data in encrypted way, and also you can store not only the patient, the scanned images. They store along with the patient images. They store the patient details. So there you can apply encryption and all those things. And there is another method to protect the privacy of the patient details. So can anybody tell me what is the method? Let us say we have a patient data with their name, age, and all those things. So how to protect the data? What is the method we have? Instead of removing that column, that attribute, without removing the attribute, we have to maintain the privacy of the user. Maybe name can be removed. What about the age or PIN code and all those things? How to manage that? Any idea? Anybody having any idea? Let us say we have a patient age. Let us say they went for diabetes. The time period of the diabetes they taken and what is the PIN code from which address they have reached and all those things. Okay, I'll come to that. Okay, so we have blockchain. Blockchain also used in healthcare industry. So it's not only in one particular area in healthcare, it is used in all the places, several places in healthcare industry. So if you talk about in healthcare industry, how blockchain is used, we have digital identity management. So identifying the patients or doctors or other stakeholders. So they use this blockchain here, and also for insurance frauds. So if you talk about insurance and financials, there are a lot of frauds that happened. You may not be aware of it. Nowadays, we have the term insurance and other things are there. So now even the suicide and all those things, they will not cover in the first year. Okay. So this what happened was in several, I think not now, around 15 years back, I think in Bihar or some other place. What has happened is it has really happened. So they marry a bride, and the guy will marry the bride, and what happens is she'll be get suicide or she'll get died within a period of 6 months or 3 months. So what they do is they'll take a term insurance, and they project her like she has done some suicide or something, but later they found that it is to claim the term insurance, you can take a term insurance for 50 lakhs or 1 crore. So to claim that amount, they manipulated those things. So that's why the insurance companies, they later they came up with strong regulations that only in the first year it is not allowed and like that. And nowadays such issues are not happening, but this is one of the issues that has happened more than 15 years before. Okay. So that is insurance frauds, and people are maybe taking insurance and they will claim from multiple insurance, and so that is also frauds are happening. And the blockchain is used in clinical research in healthcare industry and also for supply chain management. So supply chain management is one of the blockchain application. So it is used by even Deeper Group, the Diamond Group. So they use to track the I mean to the legitimate user whether they're buying it and the diamond what they having it is legitimate one or not, and before they want to sell they use the blockchain for that to all the process. So like that we have any drug also. If we talk about the drug and the medicines, so it is also a lot of fake drugs are coming up. So to tackle that, the companies are using blockchain. It will track till it reaches the customer or to the medical shop. So that is also blockchain is used in the supply chain management. Okay. And in Andhra Pradesh government, they used blockchain for particular purpose. Can you tell me anybody know for which purpose they use a blockchain in Andhra Pradesh government? I think 2 years before. Any idea?
Participant, if you know the answer, please raise your hand or give in chat box.
Okay, so they used for land registration. So for land registration, they implemented a blockchain technology, and so these are some applications. In healthcare, we have a lot of such applications. So this is one of the application in healthcare industry, how blockchain is used. So I'm covering both drug discovery and other applications because drug discovery alone we cannot cover for 1 hour. And here we have, let us say we have a patient with a blockchain address, a patient with having his own blockchain address. Let us say he go to a hospital XYZ. This is a hospital XYZ, and here he takes a treatment for let us say for diabetes, so for sugar. Nowadays we are taking people are taking barota and other fast food items, and soon in next few years the dental hospital and diabetes hospital will have a lot of requirement. People will be visiting the both the dental and diabetes hospital. Okay. And what happens is the patient goes to the hospital XYZ for diabetes treatment, and he gets treated for diabetes. So let us say they give him the report and they give him the medicines for several years and all those things, or several months, or some insulin and all those things. So those reports will be this is a report of the hospital XYZ. The first hospital he treated it for the diabetes is XYZ, and the report is stored in the blockchain address of the patient. The patient blockchain address, they store all these medical reports. So later, let us say the patient goes to a hospital called ABC for some surgery. So before going for that surgery, the hospital should know what is the treatment he has done for diabetes. So based on that only they can take a decision to go for a surgery, whether the severity of the diabetes and all those things, and BP and other things has to be checked before any surgery. So this new hospital ABC wants to access the previous report for diabetes. So what they do is the new hospital ABC who wants treat for surgery, they ask the report of the patient, which is stored in the previous diabetes report, is stored in the patient blockchain address. So the patient will allow the hospital ABC to access his previous report. So based on that report, the hospital ABC will do the surgery. They access the past diabetes report, and they'll based on it they'll decide the surgery process. So this is how the blockchain can be used in healthcare industry. This is a model application how it can be used. And another application area in AI and ML is reinforcement learning. So what is reinforcement learning? Anybody? Like supervised, unsupervised, machine learning and deep learning and all those things. We have reinforcement learning. Nowadays we had a deep seek, so which is able to predict better than uh, which is better than chat GPT and all those things. So Yeah, what is a reinforcement learning? So DeepSeek also they use reinforcement learning. Hybrid, it is not hybrid. But is my PPT visible?
Yes, sir, visible.
Okay, I think I opened. Okay, just a minute. Yeah. Now I think I missed somewhere, so I'll stop sharing and I'll share it again. Yeah. So it is mainly reinforcement learning is used in the gaming. So let us take a Pac-Man game or any other game. So let us take this is shooting game. So it will try to it will move down and we have to attack all before it has reaches bottom. We have to kill all the opponents. And this is one of the game. And so like shooting games and all those things, shooters and Pac-Man game and all those things. So there, the opponent is an AI computer based opponent and will try to attack us. So they have to take a correct step to attack us in a short period of time. So that is where they use reinforcement learning. So let me go to the concept. So some video games are used for reinforcement learning research. So we have DeepMind is there, Google DeepMind Lab. You can access that. It's for free. So where they used even for chess game, they have a DeepMind and they simulate and they're able to draw the game with the top chess players and all those things. So they used deep learning for research, that is reinforcement learning for research. They used applied for several games. These are some of the games, old games. They applied reinforcement learning, and they're able to act. The player will be acting as a reinforcement learning, and they done a lot of analysis. Okay, if you want, you can check with DeepMind Lab. So what is the reinforcement learning here is, so it has an agent. Agent is the opponent or the robot which I'm trying to attack. So in the environment, let us say the Pac-Man game or a puzzle game. So it has to take a step. The step can be the action. The action can be let us say it is moving in a one direction, left direction, or right direction, or in the front or back. So it is an action, and the action changes in the maze or the game. Okay, the position of the agent, the robot will change. The environment is the game it is playing. Okay, so if the agent takes a correct step, it is called as a reward. And if the agent takes a wrong step, or the robot is takes a wrong step, it is called a penalty. So here they use a table called as Q table. There it has all the states, and there is a Bellman equation. So that is also they used to calculate the score for each step and everything, which will leads to the goal. It has to reach the goal. Okay. So there are several type of searching techniques here. That is informed search and uninformed search. That is the basis of AI. So in informed search, we know the goal position. Then we'll go with the A star search or A star algorithm and other algorithms are there that is used for informed search. In uninformed search, we don't know the goal position. So there we apply DFS, depth first search or birth first search or limited search, and so many other searching algorithms are there, which is used for uninformed. We don't know the goal. Where is the goal position? And we'll try to reach the goal. We have to reach with the shortest distance or something like that. So there are different methods are there. So the current application area is the cube deep reinforcement learning. Okay. So let me try to finish this one fast and I will go to quantum computing application. So there are some applications of mental health. So it is a personal gen. It is a mobile app. It is available in various platforms. It is one of so it is for stress relieving. Some people will focus on the get upset with small, even a small negative. If somebody talks about them bad, they'll get upset. Okay, they got affected by the more negative thoughts. So this is a personal gen. We have two faces. One is happy face, blue, and green is a angry face. So the game, what it does is it gives the it will be a screen with the grass and all those things, and it will show the happy face and angry face. It will come. It will pop up from the grass. So the user has to click on the happy face. So if the based on how the user clicks, it will be dynamically the way analyze the patterns dynamically, because it the patient can be recovered in a different way. Yeah, all the patient will not recover in the same way. So what it does is it uses reinforcement learning here, and it tries to give complicate solutions. So some people will recover faster from negative thoughts. So what it says is you have to focus on the positive phase or on the positive feedback and all those things. We have to regulate the negative one. So that is the game about, and they use the reinforcement learning to recover the patients from a lot of stress. And deep learning also used in genomic analysis and drug discovery process. And another area where the people talk about is Alzheimer disease. Can anybody tell me what is Alzheimer disease? Anybody? Any idea? Any message in chat box? Okay. So Alzheimer disease is short-term memory loss or something like that. It will be shrink, the region will be shrink. So it leads to memory loss. So it's very difficult to identify that disease. So now people are using with the deep learning methodologies. Even some tech companies are working for Alzheimer disease prediction. So it is a brain disease. It's a small portion of the brain which was shrink. The region will be shrink, and that leads to memory loss. So deep learning is used, and it is one of the research area, hot research area in the medical field. And there is a mobile app called as a Relief Link. It is one of the topmost mobile app in healthcare field for the Apple iOS platform. It is available only in the Apple iOS platform. It is one of the top most downloaded app in Apple platform related to the healthcare industry. And what it does is it monitors the user's behavior, whether he is in happy mood or good, or he is very low or like that. So let us say the person is walking in a street, and if the mood, it will analyze the mood patterns. So if the person mood is frequently it is low, it will say that if nearby some shop, any shopping or any coffee shop or any shop is there, it says that can you take a break and have a coffee, like that. It will say. So it will give some suggestions. Even if the person is mood is very low, it may lead to suicide or some other disorders. So it will give a emergency call, or it monitors the user's mood pattern. So this is one of the topmost app in iOS platform. This is some of the companies which works the healthcare industry, and these are the companies which works on the drug discovery process. So drug discovery process, Intel also working with telehealth. Microsoft is for vision care. Even Intel is working for telehealth medicine. And this is another game, that is a Flappy Bird game. This is a variation of Mario game. So people would have played a Mario game. This is a variation of that. And there is a research paper which was published. It is called as a Flappy Bird game. So it reduces stress. It's mostly we also play game to reduce the stress and all those things. So, but there is a research paper have been published on based on this application. It's a variation of Mario game using, instead of Mario they use a Flappy Bird. So like this also we can take some lot of researches are going on. And another research work I have found, I have seen is some college students. Let us say a person is having a fracture and he wants to get treatment for that fracture. So what happens is the recovery of the person varies based on the age and their stamina and all those things. So not all the persons having a similar fracture will be able to recover on the similar patient patient. Okay, so what they do is they develop the mobile app or some system application. So they track the patient exercise mode. Let us say we have a hand fracture, say they'll give you some exercise after some period of time. They ask them to raise their hands and all those things, some exercise they ask them to do. So that exercise it will be monitored by this app or the application, and it will give variations of where deep learning will be used. So if the person is able to do the exercise better, recovering faster, so it will try to give more difficult exercise so that they will be able to recover in a quicker manner. Okay, so that they use the reinforcement learning. So this also can be taken up as a research work and as a project. So let me skip these things. Virtual assistant, I already talked about. It will monitors the patient. It will give the reminders. The hospital, it will be like a hospital app, which reminders the patient to take medicines and it will book the next appointment and all those things. So it's like monitoring the patient virtually. So, in case of drug discovery process, the pharma companies will prepare the drug, and we have the tech companies will provide the computational facility. And these are the AI-based companies which they work with the pharma company and the tech company to produce they do for drug discovery process and other analysis analytics. So let me skip these. Some of the data sets are available. Okay, so let me skip all these things. Let me go to uh, uh, yeah. So before going into some deep learning models, we have Google teachable machines. This is AutoML and auto deep learning model. So here we do not to have any code or anything not to be done. Just we have to upload the images, and you can click on the training, and it will create the it will generate the output. So in this case, in this example, it has two folders. The girl is capturing her photo in one folder, me, and another folder is me with the dog. With the dog toy, she's capturing the images, and on click on the training, it trains with this data set. And in the prediction, she predicts with the live camera whether it is predicting whether she is with alone or with the dog. Okay, so here this is called as auto machine learning and deep learning model. So it is in Google Teachable Machine. It can be, you can access it for free. So here not only for two classes. If you have multiple classes, let us say we have a cancer, we have different types of cancers are there. You can upload an art class. You can have multiple classes can be uploaded, not only for two classes. You can have any number of classes. You have to upload them each set of classes into a different folder, and you can get the output. And in Google Teachable Machines, we have three applications they provide for auto deep learning model. One is for image classification. This is for image classification. And another one is for music or audio classification. And the third one is for post detection, like yoga post detection, like that. So that is the three applications they provide, Google Teachable Machines. Okay, so how you can use it, the ChatGPT or other platforms is we have to, you want to do research, you want to work with some latest data set. See, then first you identify what are the latest data set, because people, if you take uh, like intrusion detection, NDDD cup data set, they use it. Okay, it's a old 1990s data set. Now, if you want to work with some latest data set, you can try with identify. I mean, what is the latest data sets available for some particular field? Even you can try for drug discovery process. Any data set, latest data sets are available. You will get those data sets. Then for that, you can generate a model code or any particular model code you can generate. So this is explainable AI models. So we skip these things. Uh, We go to this. Okay. So there are traditional models. We have black box models, like we have machine learning, or deep learning models are there. So what the model will do is for the input image for medical data set, we apply the model, whether it is a deep learning or machine learning model, and we'll get the output as prediction, whether it is a cancer is there or not. Okay, but what happens is the doctors will not believe these results because they don't know how the model works. Even we cannot explain how the model works because we give the image, we get the output. We don't know how the model is analyzing the data or which region is given more importance and like that. So for that, we have explainable AI. So what explainable AI will do is it gives you the explanation about the which region is giving the impact for the result. So in this case, this row you can see this is the input image, and this is the prediction. Like there is a cancer infection. So it can you see the dark color. It is, I think it is in some purple or some other color. It is there. So this is the explainable AI. So it gives that this region is impacting uh, the results of this model. For particular model, you are getting whether it's a cancer or not. It is able to analyze based on this region is giving the more impact from other images, other normal images. So that is what explainable AI models are used currently. People are working on that. So this is a chest X-ray. It is a COVID analysis. So it is able to detect whether the person is having a COVID or not having a COVID. So based on these regions, so these dark color regions, these are the regions which has given the impact whether the person is having a COVID or not. The remaining regions which is not giving the impact for the model to analyze. This is what how explainable AI works. Okay, so let me skip these things. Another thing I talked about the privacy is data privacy is we have to use anonymity. So here the actual data will be the patient data, like it will be the particular age. So what they do is in anonymity they replace that data with some range. Okay, that is what anonymity, care anonymity. So it is for protecting the privacy of the user. There are a lot of variations are there. You can also you can also do previous works or projects can be done on this anonymity. So let me skip. I think I'll cover some quantum applications. Let me skip this. I'll open another PPT. I'll stop sharing and I'll share again. Just a minute. Okay, let me share the PPT. Just a minute. Yeah. So I think already people have talked about quantum computing and these applications. I mean the basics of quantum computing. So I'll quickly go through that. So usually the bit we have 0 or 1. In case of qubit, it can store not only 0 and 1, it can store both the values at the same time. So that is a concept of qubit. So how it is evaluated is based on the spin up and spin down position of the qubit quantum, whether it is the position is in the up position or the down position. So based on that, we retrieve the data. If it is an up position, it is a 0. If it is a down position, we retrieve the value as 1. So in classical qubits and classical bits and qubits, so the number of qubits equivalent to the number of classical bits is you need let us say you have two classical bits 0 and 1 the same 0 and 1 I mean 2 bits you can store 0 any one value or one possible combination. Either you can store 00 or 01 or 10 or 11. Any one of these values can be represented from two classical bits. But in case of two qubits, you can possible to store all these values. It is based on the current position of the qubit. So if it is in the up position or down position, if the both qubits are in the same position like that, based on that we can able to store all these possible values. So I mean that is equivalent to 2 power n possible combinations. The two qubits you can store 2 power n data. So that is why the supercomputing, I mean, the fast processing of quantum computing is possible. Is another example. The same numbers, you want to store all these 8 patterns. For this, you need only 3 qubits is required to store all these patterns, 002, all these combinations. You want to store 8 patterns, you need only 3 qubits. But if you want to store these all the 8 patterns, you need 24 bits to store. In the classical bits, you need to store all these values. You need 24 bits. So that is where we have a difference. Let me skip all these things. So it will be 2 power n. So if the number of classical quantum bits equivalent bit is, if the three qubits is there, equal number of classical bits is required is 2 power 3. That many classical bits are required. For 10 qubits, it can do equivalent processing of 2 power 10 classical bits. That is 1024 bits. Equivalency will be done with only with 10 qubits. So if you have now we have some quantum computers, they are planning to develop with 100 qubits and all those things. You can see the computational power of those quantum computers. Okay. So why they are able to do calculations faster is because of the calculation they are able to do with qubit. They can store more data. That's why the quantum computers will be able to finish it, the analysis and all those things faster. So one of the application is quantum warfare applications. I didn't add it specifically for drug discovery. It's just I'm covering some what are the methods you can use it for drug discovery. I'll cover now. So here the main problem with quantum computing is the temperature. It has to be stored with minus 2 degrees Celsius or 1 Kelvin. Otherwise, the data will get corrupted. The qubit, the position will change. It will affect the reading the data. Okay, that is the main issue with quantum computers. And decoherence issue. So the quantum states will get affected. It will what you can say two qubits can leads to decoherence, or it can be an coherent based on the if it is if there is an impact of the local temperature or the other what you can say a local environment, it leads to a decoherence of the data. So this is a decoherence. It may have heads or tail, but if there is any fluctuations or temperature or any environment, this one it can change its position to any one of these values. It cannot read both the values at the same time. So that is the problem with the loss of coherence, or we call it as a decoherence. And another one is entanglement. This is one of the characteristics of quantum computing. So here, two qubits can be entangled to each other. If it is one is red, other may be a blue. If one is blue, other can be a red, or both can be in a same pattern. So if the direction of the rotation is in the same direction, it will both have the same value. Or if it is in opposite direction, one is in opposite direction, it may lead to a different value. One may be in a 0, one may be in a value having 1 based on the direction. So let me come to the this is a quantum entanglement issue. So let me skip some of the slides. Okay. So there are several simulators are there, but they are able to simulate only 2 qubits or 4 qubits in the classical computer. So they cannot go beyond that because of computational complexity. Okay. And see potential applications. Here we come up with the drug discovery process. So here, the number of, based on the applications, the number of qubits required. So mostly the optimization and the drug discovery process comes from the chemistry, drug analysis. So for optimization also, that is the simulation environment and all those things, we use drug discovery process. So here they use 100 to 1000 qubits are required, and similarly for drug discovery or chemical component analysis, so we need 100 to 200 qubits is required. But if you want to do apply machine learning, 100 to 1000 is required. For material science also 1000, 100 to 1000. For unknown problems, so we need 1 lakh qubits is required to analyze unknown problems. Okay. So, and why quantum computing can be used in the drug discovery processes, the optimization. We have to identify the specific compound. Okay, so there they use a lot of optimization methods to identify the best compound combination. So we have a local optima and local the maximum minima. So what happens is the normal traditional process, like a hill climbing approach. So it may be leads to a local minima, and to avoid that is a problem with the classical traditional methods. But in case of quantum computing, so it has a concept called tunneling, and another method is called as annealing approach. So I'll come to that annealing approach. So here in tunneling approach, even though it is in a it is reaches some barrier, it can cross the barrier and it can do the next computation. That is in quantum mechanics. So that is called as quantum tunneling. So it will not lead to a local minima or such issues will not face it in the quantum computing if you use quantum computing for such optimization problems. So optimization problems comes mainly for drug discovery process and other applications. And there they use quantum tunneling. And another one they use it as quantum annealing approach. What is a quantum annealing approach is, I have not added the people, just a minute, we'll check. Be in line. Just 5 more minutes, I'll finish it off. I think I said somewhere, just a minute. I'm just trying to get it a quantum annealing information. Yeah, I got it. Just trying. Which is a basis for quantum annealing is a main application is for optimization, and where it is used in like for drug discovery process. Just a minute. Yeah, this time. Yeah. So classical computer path, it will have a tunneling. I mean, it will leads to local minima and all those things. But in case of quantum computing, it has tunneling effect. So even if it has reached a local minima, it can able to proceed further, and it can do. You will get a better solution. That is a benefit of quantum tunneling approach. It is used in optimization and other approaches, which will be helpful for drug discovery process. And here they use this is a quantum annealing approach. So this is a quantum annealing. Uh, so this is an annealing approach. So what is annealing approaches? Here what they do is they can the position of the state of the qubit, it can be 0 or 1. So they can change it position from 0 or 1 so that it can able to analyze in the, I mean, the region. We want to get the better the error rate. I mean, this is the error rate. We have to reduce the error rate and we have to identify the best possible solution. So this way of changing the position of the qubit, you can able to analyze quickly to get the relevant solution. That is annealing approach. And here what they do is if they want to have a preference to some particular value, let us say instead of 0 they want to focus only on 1, they can apply external magnetic field and they make sure that this qubit stays in the value of 1, so that along with tunneling approach, this is annealing approach, and we can be able to get the more required solution in a faster way to avoid local minima and other things. So that's all about this thing. There are some frameworks are available. IBM Qiskit is one of the famous one, and we have a Circ is there, Google Circ is there, and Amazon Bracket, Microsoft Q Shop is there, and Rigetti Forest. Pennyline is one of the famous one. You can try this. It is like an integration of several development kits, Qiskit and other things can be integrated with Python framework. That is a Pennyline. So that is another what you can say. It is like multi frameworks or some similar to that. QSIM is India has developed. CDAC has developed the QSIM toolkit. So let me skip all these things. Yeah, Pennyline. So Pennyline, it is you can try this. It is an AI-based tool which allows you to integrate with several along with the Python. I mean PyTorch and other things. You can integrate with all other different even Google Search, or you can IBM Qiskit. Everything can be integrated together. So it's a new platform is available for quantum computing application. It's open source, so it is free to use. So here, among these various approaches, so mostly the quantum annealing approach and quantum tunneling, these methods along with the deep learning models, it will be used for mainly for drug discovery process. And we also use the reinforcement learning, can be also used for drug discovery. So I'm skipping these slides. Let me go to the, yeah, that's all from my side. Any queries?
Participants, if you have queries, raise your hand. I'll enable your mic. So there is a question in the chat box.
Yes, madam. I'm just
Why is the circuit-based quantum simulators more popular than annealing-based ones?
No, circuit you have to design any quantum computing. You need to design the circuit. Then only you can apply the quantum methods. Annealing is one of the approach to maintain the how you are maintaining the qubit position and all those things.